Good. Thanks for joining. We'll get started with Unit 3 of the HuggingFace diffusers course that has 2 notebooks, and I'll also briefly touch on Stable Diffusion Deep Dive notebook. So this is the first of the 2 notebooks where he uses or illustrates the use of varying pipelines, and also looks at the code for the various components of the diffusion pipeline, which we are familiar with by now. The variational autoencoder, the tokenizer, which tokenizer and text encoder are things that we did not look at in the FastAI course because Jamie referred it to the language model or NLP related discussions. We spent a lot of time obviously on the unit and how that was coded up, and then of course the scheduler and exploring the different schedulers. The couple of different pipelines that we'll get to play with in this notebook are the image to image. So you provide one image as a reference and want to create images other images which look like the reference image that you provide to the diffusion pipeline. And the other type of pipeline is also something used for in-painting. We've seen a little bit of this, I believe, in early part of FastAI course, where he kind of illustrated how you could change the fruits in a bowl or the nature of the bowl itself. Stuff like that. We'll see slightly different uses of the same technique, and then also refer to how the same technique could be used to produce 3D versions of images and change the textures and stuff like that. That's referred to in a tweet. So the setup and everything is similar as before. We pip install the transformers, and then we download a bunch of pipelines. And you can see that there are various different types of pipeline. There is the standard diffusion pipeline, but there is also the image-to-image pipeline, which will illustrate the usage of, and then the in-painting pipeline, and then the depth-to-image pipeline. He just kind of downloads a single image from the web. You can use your own image. And I also looked at, here's the image he uses, that of a dog. The interesting thing is you also create a mask, which is used for in-painting, and 2 other techniques, which you can see is just the outline of the dog. So I was also looking for how do you create in-painting related masks. So there are some various things you can search on the web for how you can create the mask, which will allow you then to do this. Moving along, we kind of load up the CUDA, the base pipeline, and if you run out of memory, but actually I was able to use V100 and get everything working without any additional changes, but you could use the FP16, or you could even use something called attention slicing, both of which are techniques to reduce the memory usage, given that we are working with significantly bigger sized images than just MNIST and stuff. And you see a nice painting where it says palette knife painting, so it kind of understands the style, and you can see that the painting is that as described of an autumn cityscape, and it also understands the style, and you can see peculiar to the palette knife painting style. And then he says kind of play with this, and I in fact did. I provided a different prompt, an oil painting of a rainy London street showing a horse-drawn carriage and people, and it did generate the horse-drawn carriage, although it seems to have put this carriage doesn't seem to have anything drawing it. The horses are kind of off by themselves, and people aren't looking too great as in some of Stable Diffusion's problems. The generation of people's faces and bodies and stuff aren't the greatest, but you can see it kind of captured the essence of whatever. And then this is more of, can you control the guidance and what should the guidance scale be? And typically, as we've seen before, something in the 7 to 8, and you could go all the way, I guess, from 1 to 15 or even 40. I've seen in some cases. And the prompt that I used is a husky with a pink hat. You can see when the scale is low, it kind of struggles with generating decent image following the prompt. When you increase the scale to about 8 or 12, when we say typically in the range of 8 to 12 is when you get the best image, and you can see that that's true. It creates really nice images of a husky with a pink hat. I also originally tried this with a husky with a teal hat, and an illustration of, the capability of GenAI is somewhat dependent on what it got trained with. If you try this with, a husky with a teal hat, for example, it just gives you a block of teal color on top of the husky. It kind of knows that a hat is supposed to be on top, but I guess it hasn't seen too many teal hats, so it's unable to produce as good an image as this. And I thought that was kind of interesting, that while it produced a husky images as good as this, but it wasn't able to produce the hat images. So it seems like it's the ability of the model depends on what it's been trained on, because if you give it a teal hat or something like that it hasn't seen before, it kind of struggles to generate that. Just correspondingly, I just wanted to show you that the corresponding thing in his original notebook was a collie with a pink hat. And again, the hat looks different, as you can see. The collie looks pretty good. Again, it was a pink hat. So I wanted to change it to a teal hat, which is why I tried with a teal hat initially. But as I mentioned, that didn't give a very good result. So in that sense, I think diffusion models still have these kinds of issues where they aren't very precise in terms of your ability to control. Of course, you could play with it and train it on a few teal hat images, and that would fix the problem. But all I'm saying is it requires additional effort than just a description. This next portion, we just look at the pipeline. We've seen this many times before, but basically going through a, it just says you go through a autoencoder, variational autoencoder, generate the latents, from the latents, do the decoding, and then do the upsizing to the full-sized 512 by 512 image. He just illustrates that when you encode the image, you go from the 3 channels 512 by 512 size image to a 4 channel 64 by 64, and then back to the decoding to the original size of the image with the 3 channels and stuff. And then the rest of it is not all that interesting. He also goes through the clip encoder, where you take a textual description of what you want and then tokenize it and then pass it to the text encoder. This is something that we have not looked at in detail in the past AI course, because he was deferring it to the NLP portion of a future course. So the text encoder, basically what it does is it takes a textual description, converts it to a set of embeddings. Those embeddings would be very much like the time step embeddings that we saw in great detail, how the time step embeddings are converted, or how the time steps are converted to a time step embedding and then passed into the unit. We saw the combination of sine and cosine waves that get combined to generate the embeddings, so that in the embedding space, things which are similar are close, but also gives enough variety as well. So the same kind of thing we'd be doing in the text embedding portion of the stuff, and that's what is described in this text. So he takes the sentence, a painting of a flubble, and then kind of illustrates through a clip text encoder. However, when I try to do the same thing of text, the underscore encode prompt, which I'm assuming the underscore preceding would imply that it's done in place. But for some reason, when I tried the shape, it didn't like that. But actually, as you can see, the text embeddings themselves show you the vector or the tensor, I should say, of the embeddings, which is kind of the point of the exercise, to show that what you have are embeddings of certain size and shape that you have converted the text to. And then this is the description of the unit and the scheduler and the time steps. The latents are just something randomly chosen of 1, 4, 64 by 64, and then you also provide the text embeddings, and you provide the latents, the time steps, and the text embeddings, as I was mentioning before. And what you get out of the unit is the shape of the latents. And then the scheduler, we have seen various schedulers and description and discussions. So here, if you can just swap in, he's just illustrating, you can swap in a different kind of scheduler. So he uses the LMS discrete scheduler. And here I just try to generate, or actually this is his original prompt, palette knife painting of a winter cityscape, and it kind of generates a nice picture with the particular style. And again, I try to generate something similar to what I'd done before, but with a different prompt, oil painting of a rainy London street. And this time it kind of generated many people on the street and a couple of carriages as well. And he then shows that you can put the various things we have seen, the guidance scale, the number of inference steps, and also a prompt, a textual prompt, a positive prompt, and a negative prompt, which I haven't seen before, that this idea of a negative prompt, that is things to stay away from versus things you want. Text embeddings, latents, and then add the noise, and then set the time steps, and then loop for about 30 times, as we've specified the number of inference steps to be 30. And you kind of decode, as we have seen many times before, and go through the leap, go through the loop, and finally produce the output image, which is a nice image of wave breaking. And obviously, he says, hey, you could just generate this using the scheduler and using existing pipelines, but having or illustrating the code to go through the loop allows you then to modify or tweak individual elements of the loop that as you would want it to be tweaked. And now we look at these additional pipelines, like the image to image in painting, and also see what kind of limitations they have. So this is the work we've seen so far is on stable diffusion. We will towards the end also look at the stable diffusion deep dive. We have looked at that at the beginning of our FastAI course, but it'd be good to retouch on it towards the end of this discussion. And then the image to image pipeline, excuse me, is you load up the basic diffusion pipeline, which is the model ID, and then you create the stable diffusion image to image pipeline from the pre-trained model, and the pre-trained model we are using is one base. And what this does is It
I faced
takes,
an
so the
out
image,
of memory error here in the
you actually mine, when you do this, you're getting an output error, you're saying, mine?
out of memory OOM.
Oh, okay. Yeah, I think that's part of the reason he says that you probably need, um, you know, he mentions, did you try it with, for example, the FP16? Although
No,
I don't know whether, the GPU you have will support FP16. So you could try this other thing he mentioned of attention slicing. I haven't looked into the details of it, but that seems to be another way that he talks about the fact that, you may run into memory problems because the images that you're working with are all significantly larger. He talks about,
yeah, I tried that. I tried this both of those things in my um yeah the enable attention slicing and those FP16 floating points. And I was able to run the first part, but I didn't try that in the second part.
okay. The other thing you may want to try, and this is something I kind of, unfortunately, it's one of the drawbacks of this notebook. Well, I mean, it would be true even if it were a notebook, but the sequentiality of these notebooks kind of makes it somewhat of a problem because some of the stuff that, by doing these things earlier, you're kind of loading and using a significant usage of the GPU memory too. So you may want to initialize it and then skip the earlier portions and directly go to just loading this pipeline. That might be something else you want to try. You know what I'm talking about?
Yeah.
Like instead of going through
Hmm.
these steps and polluting your graphic card memory, um, just directly initially load what you need for the setup and then directly come to this portion and just load this pipeline, the image to image pipeline. That might
Hmm.
get you through as well.
Yeah.
Another thing
Okay,
to
I'll try
try.
that.
So in this case, the image to image pipeline, set. So for example, the setup, the image to image pipe, this is where he loads the initial image. That's, by the way, something else that you could try is reducing the size of the initial image as well as the size of the eventual image that you output. If that would probably require a little bit more of um, playing around with stuff because the unit output is probably fixed based on the unit that's being used. But for example, the input image here is a 512 by 512 image, which obviously takes a lot of memory. So you could try giving it, say, 256 by 256 or even a 128 by 128 and seeing whether it outputs a 128 by 128. That might help too, in addition to what I said before. Anyway, the original image that we are using, and this is where why I was also looking into how to, the original image that he uses is this. And to use the ink painting, we also need the mask. So that's why I was looking at, and there are various very easy find how to generate the mask offline. You can do it in any kind of a paint program or something like that on your desk. But what I found also interesting is once you get this dog image and you try it, I kind of changed it to an oil painting of a woman on a bench. So it does create a pretty nice image. But what is fascinating about it is because there is this tail of the dog, and you can see even in the mask, there is this tail. And that in turn causes some problems to the in painting pipeline because I also tried this palette knife painting of a man on a bench. As you can see, it's not as good as this image. For example, he just seems to be hanging on top of the bench. It's not sitting on the bench. The other thing you see, which I saw in multiple images that I tried to create, is because of this thing here and the corresponding mask, it creates something like a leg here, which it tries to cover up this particular part because it says, oh, this part is part of the dog as well. So when I replace the, remember, because the pipeline is an in painting, so it tries to in paint everything in the mask. And interestingly, in this case, because the leg of the woman is kind of aligned with this particular location, that's not a problem here. So you have to, I mean, I played around to create a better image here. So this is one of these things where I was saying, it's interesting if you know, for example, then that this is what you're intending to do, then maybe in your mask you go in and remove this part, in which case then the generated image probably get better. But these are the details when you play with these things that you begin to understand or appreciate. And you can see again the face is much, it's not as good. And this is one of the known problems in stable diffusion, although I believe that in the latest versions of most of the stable diffusion pipeline, these issues have been fixed, meaning that they've gotten better at producing faces and body parts. But that's the image to image pipeline usage. Then you go to the in-painting, and in-painting is, again, just changing portions of the image and leaving other portions of the image. And that's where he talks about the mask, and the mask should be the same shape as the input image. And you can kind of tell it which portions of the image to change it, which portions not to. I think there was a better example in one of the earliest Fast AI notebooks of where he shows a bowl with different fruits and he changes the fruits in the bowl and he changes the bowl. That's an example of in painting. And here is the example of in painting he uses here. So here's the input image, here's the mask that we saw earlier, and then it says in the prompt, a small robot, high resolution, sitting on a park bench. So, here's a dog sitting on a park bench. And interestingly, in this case, it does not seem to have the problem with the fact that there is a mask below. I thought that was interesting as well, that painting image pipeline, which is what is used here, stable diffusion in paint pipeline, doesn't seem to have the problem that the image to image space does, because in image to image, it seems to want to replace all the image. Again, I haven't played, or maybe I did. I didn't. You could potentially try generating, say, an image of a man or a woman sitting, or some other animal sitting, and see whether it again runs into a problem because of the mask. So various things that you can kind of play with on that front. And then I won't bore you with the documentation of caching and stuff like that you can look. So depth to image, this also is interesting because you can kind of go and generate depth information in addition as an additional conditioning, and how and what it does that. Again, in paint with a prompt for what we want the result to look like. This is in painting. I have played with it. So there's the man, and as you can see, the face is pretty impressive. But again, you can see that this portion of the dog's tail is covered up by the man's leg, so it's okay in this case. that the structure is faithful to the. It's just various different techniques, although in the depth thing, this is not a good illustration. There is here's a tweet that where a person shows what you can do with Blender with a single prompt and using stability AI depth model. So you can see, just take this entire desk and then you can provide different textures. And the whole tweet goes into all kinds of ways that depth can be used. The mesh of a face, and it provides a nice image of face that looks like. Then kind of using some simple colors to guide image generation. And this is the whole version. I think I checked into his latest tweets because this is obviously a dated one, but even they have improved on this even more. I think there's much version of this software and the depth feature that give it AI. So that's the first notebook, the various things you can do with the image to image, in painting, depth, all these different types of things, and what you can do with them and how to modify them and how to work with them. That's kind of the first set of first notebook. The second notebook is even more interesting. They had a hackathon, I believe. Again, I want to spend more time on this and play with it in different ways. I haven't done that yet. I just wanted to run the notebook as is. So the first thing in the Dream booth, they had a contest to use the technique and come up with images and win prizes based on the votes of people as to how creative your output has been and stuff. And again, to your point, Mayank, it talks about you need at least 14 gig of GPU VRAM in order to run the notebook. I think, fortunately, Colab gives you the V100 or even the A100. I was able to run it with just a V100. I think A100 has even more, but of course it compute cycles per hour than the A100 does compared to the V100. But V100 is good enough for this. So Dreamboot is just technique to teach new concepts to stable diffusion using fine tuning, which we have seen before as well. Give a few images and allow it to kind of fine tune on that. That allows you to provide a base image off of which it can play with. And here is an kind of a very interesting example of, if you haven't heard of Andres Karpati, you should look at, he was one of the original TAs of the computer vision course that was taught at Stanford. He was a TA for that and subsequently went on to work at OpenAI, then Tesla, and I believe now he's back to OpenAI after being on his own for a little bit. Some of his Colab notebooks and postings and discussions on gradient descent and things like that are pretty interesting and legendary in terms of the popularity of those posts and the explanations that he provides. Check out his YouTube and Colab notebook postings if you haven't, but this is an image as of him as a samurai, as a doctor, and which are pretty cool looking. These are some interesting steps as well as this using stable boost. So here it just kind of explains how Dreamboot works. You just select 10 to 20 images of a subject and then define a kind of a unique identifier that's different from any normal word in the English language. and let's say, fluffy dog or something, so that you can distinguish, or it's again a way to allow the text embedding creation to create an embedding that is unique and that represents the concept that you're trying to implement, which is that of your face or your pet's face or something like that. And then fine tune the model by providing these images together with like the textual description. And the V here, or the bracketed V, tells it that it's a particular type of dog. So the dog is a class, and this particular embedding or word or character then represents the concept of your pet dog, if you will. And then you could potentially also use a class-specific preservation loss. So in fine-tuning this, what you do, you provide the textual thing, you provide this along the image, along with the class that's of dog, and then the output is this unique identifier, and then the personalized text to image, so that when you do the inference, it's able to create the image, and you can modify where and what you want to be done with the concept that you provided the model. So for example, a V dog, it means a pet dog on the beach. So here it's able to put it on the beach and walking on a colorful carpet, it's able to do that, things like that. So, and various things that you can do is things like, seen from the top, seen from the bottom, things like that, various images from different angles. Also look at this cute thing where you can kind of create, give it an input and then say, oh, I want my car to be violet, purple, red, yellow, various color shapes, kind of neat. And here he has different images generated of base face of a dog in the form of, and this is very similar to Karpati in a variety of different roles as a samurai, doctor, medieval king, and stuff. Right. So, you can play with this. I didn't, this would be interesting to try with different concepts. Here, I just stuck to what was in the notebook, use an animal. He provides the corgi face. There are various videos of how to upload the data set to the hub and on that you can follow on your own time. And then once you create the data set, how to kind of download it. Here's the face corgi and the faces of it, and then create the training data set, create instead of the bracketed V here, you use a C corgi to create your own, if you will, make up your own word so that it refers, it's not identical to any prior word in the English language, so it better be a unique identifier. And then there's a class, and then a photo of the name of your concept, which is C corgi, and a type of thing, which is a dog. And then use the data set and the Dreamboot data set, which is a subclass of the data set, and take the clip tokenizer and kind of train that, do the data collation, which we have seen the difference between typical data collator on PyTorch and then the HuggingFace data collator. HuggingFace, if I recall correctly from the first year course, it's and stuff, so you can look at the details. So you collate the collate function or define the collate function, which in this case also includes the prompt ID and the images, create the input IDs, create the batch, which would be the text along with the image, and then load the components of the diffusion pipeline, which we have seen before, the VAE, the text encoder, the unit, and the feature extractor, and then fine tune the model. This is the part where you're training it to be capable of utilizing the image, customized image that you have provided. or customizing it on the image that you provided, and then this is just a training loop using Accelerate and Sylvain Dugan, who is the um, author of the Accelerate module, if you will, from the HuggingFace, which allows you to control a lot of things, including SP16 training and multi-GPU training and so on and so forth. And you'd use the accelerator, um, accelerate to train, fine-tune stuff, and you go through the fine-tuning process and create the pipeline and save it and do the training yourself and then run the inference. So when you run the inference, you can say, and something that it changed in the, let's look at the original stuff he has. It does, let's look at prompt that he provides when he does the inference of his core B showing up in here. It's a photo of this at the Acropolis, in the Acropolis. So it kind of, since he says in the Acropolis, kind of shows it in, and you can see these columns, like the columns of the Acropolis. And kind of modified it. I modified it to say a photo of this at Taj Mahal, kind of stuck the Taj Mahal in the background of the Corby. That's the concept. And it'd be also interesting to see whether if I put in the Taj Mahal as to how the image, whether it would have, that's something else to play with as well. And then the rest of it is just pushing the model up. But I think more interestingly, it would be fascinating to play with, things like these categories that he talks about. I intend to do whenever we will play with themes. Animal themes is what he has illustrated, but it'd be fascinating to do it with food, or I have pictures of flowers. So I wanted to kind of play with it to landscape it generates, and then of course something. So that's Dream Booth, and apparently they had a competition. I haven't gone out and checked. I've been much more creative with images that they generate using Dream Booth. And as I mentioned, I also went back because he's referring to the Stable Diffusion Deep Dive notebook. So I went back and tried to rerun, and sure enough, one of the things I found out is it runs into some problems. And it's fascinating because things keep changing and people keep updating. So this notebook, it runs into some problems towards the end. I believe that has to do with changes in the underlying libraries. This is the same notebook, what lesson 9A, I believe, of Stable Diffusion, the first AI course that we went through. And just the same setup as before, and we've seen there's something times all the different times. And then he just talks about diffusion loop here. I believe in his original notebook, he does the prompt that he uses is that of an otter. So he gets this image. and I changed it to that of a raccoon, and I got, and obviously this is this loop by now a lot of times. Um, I'm not going into the details of it, but basically then go to the inference loop and do the latent scaling and utilize the scaling to get back the RGBs. And this is the image. But when I said a raccoon, there, this is an otter, image of an otter, and the image of the raccoon that is stated. And then we've seen this before, so I'm not spending too much time on it, but just the various components. This is the pillow Python image library to latents to pillow image, and he just uses the macaw color image. Right? And when you add noise to it, what happens? And then looking at the noised image at various levels of noising, and then getting the decoded latents back through the VAE, and this image looks almost identical to this guy. It's very hard to notice the difference. Stare at the eye if you want to really find out what the differences are between the original image, the recreated image. After having gone through the VAE. So then talks about the scheduler and times, and then there's the noising stuff. And actually here is the code for what happens when you say the scheduler dot add noise. So you can kind of actually stare at the code yourself, and how the sigma stuff, depending on the time steps, get added. And then kind of the inference, and through the inference, he produced a colorful dancer Nat Geo photo, which is what is his original prompt, right? And you get a pretty interesting image, which we see. Or you can see the colors from the macaw being used. And I modified it to something saying a colorful Indian dancer on stage. Sure enough, it gave me this picture, and you can see dress and colors again are the same that have been used from the macaw, but it was able to grasp and change the concept. Here is the that is generated corresponding to colorful dancer Nat Geo photo, colorful Indian dancer on stage. And then, of course, he goes through the same textual embedding related discussion. And here he just wants to modify the word puppy with something else. And the encoding stuff is for the particular word that he's trying to incorporate, which takes you through all the various embedding discussions. And then talks about how you also have to combine. We've seen this of token and position embeddings. Actually, sorry, we haven't seen this part. We just saw the time step embedding. But this is a little more discussion of what happens for textual embedding. So textual embeddings also have just the word embedding, which is dependent on the vocabulary of the words that we use. But in addition to just having a pure embedding for the words, there's also a position of the word in a sentence that needs to be encoded as well. And that's where you combine the token embeddings, which have to do with just encoding the textual description or the text of the word, and then the position of the text within the sentence also has to be encoded. And those two things get combined to create an input embedding. And then he just takes you through the manual steps of creating the embeddings, and then says, look, you get the same thing when you go through the text model embeddings. And then you feed the embeddings to the transformer blocks. And here he says, using the text encoder's forward method, can we provide an embedding, for example, of a cat, and have that convert to an embedding and then use that embedding. So instead of a puppy, kind of provides an input embedding token in this vocabulary. He knows that 2368 is a cat. And so then you do that, and then you generate the output through the inference loop, and lo and behold, you get a cat instead of a puppy. Then this is the more interesting part, coming back to the various tricks that you could play with the diffusion pipeline and stuff is, okay, now that we have generated a single textual image, dog, a raccoon, or an otter, can we create a chimera, which is something that doesn't exist, for example? So, but here he's just initially changing the puppy to something else and generating that. But textual inversion is the part where you get a token embedding for a cat, but what if instead we could learn a token embedding for a, let's say, concept? And the concept here he's using is that of a style. So you could, for example, provide, and you can check out the verb style. He's kind of provided various images, if you will, of the verb style in the HuggingFace. This is a library, in the as a data set, and he uses that verb style, which is this style of image. So here is just a mouse in the style of a puppy. So this is mouse in the style of a puppy. So I kind of try to change using the same style, but different prompt. Instead of a mouse, I change it to a raccoon, and it kind of created something, but this seems more like a cartoon, and it seems to somewhat think of it like a skunk or a panda or something. So not the best image of a raccoon, if you will. But the interesting thing is it's more the style that we are focused on in this case. Right? And then you can, this is the chimera stuff that I was referring to earlier. So you can, given that now you know that the words are getting converted to embeddings, can you create combinations of words as new? So for example, a mouse and a laptop, and then each of them in the embedding space, or convert each of these words into the embedding space, but then mix up the embeddings, if you will, using some weightage that's applied. So you apply a mix factor of 0.35. So it's 35% mouse and 65% leopard. And his image, I changed the factor, if I recall, because I wanted to see what impact that has, what he does. Yeah, so in this case, I've retained it. I guess the mix factor is 0.35 that he uses. I believe I use a mix factor of 0.35. You can play with this mix factor, and it will change the weightage it provides to each of the two concepts that you are using. So for example, if you change this to 0.65, this will be 65% mouse and only 35% leopard. And you can see what a mouse leopard chimera looks like, where the face is being changed, but cuttings and stuff are very much that of a leopard. And I kind of tried a raccoon and a leopard, and I used 55%. So this means that it's much more a raccoon, slightly more a raccoon than a leopard. The result I got. See that the spottings are not as strong, but the face very much looks like a raccoon. Whereas here, the spottings are pretty strong. While the face looks somewhat like a mouse, it looks much more like a leopard. Here, I kind of changed the X factor, and this is what I got. Then this is where I ran into trouble because this is the inference pipeline. So I was trying to create a palette knife painting of a skunk in a top hat. Prompt here in his original notebook. Yeah. Here he creates an oil painting of an otter in a top hat, and then we've seen this before, but you know, it's from pure noise. But this is where I ran into trouble. And for some reason, the more stuff no longer works. It talks about some out of bounds. I have to talk about why the scheduler seems to be having has something to do with the indexing steps and being out of bounds with respect to trying to use. So I kind of, that's the last part. Here we're seeing classify guidance and change the color of it and stuff like that in a prior notebook. So it's not that interesting. But you know, this is something worth debugging to figure out what's gone wrong. It used to work just about a couple of months back, so it might be the scheduler or underlying code for the scheduler interface change. Of course, I could also do a try. Here is using the scheduler. The other way to do it is to generate the X0 yourself by calculating it. Maybe that's what I'll switch to and see whether that works. That ought to work because I think this has to do more with the scheduler. Maybe they've introduced checks for the scheduler and the checks didn't exist previously, and now it's checking that it cannot exceed some index bounds, and it didn't used to do that before. And that's why it worked before and doesn't work now. So things like that tend to happen as libraries get better and advanced and so on. And obviously, he is talking about diffusers 0.4 and above and 0.3 and below. And I think right now we are at like 0.20. So you can see that there's tremendous amount of change in the code that's happened since when we started. Since when he explained, which was, I believe, late last year or early this year. And then, of course, we are now towards the end of this year itself. So quite a bit of change. Anyway, that's it. And then we have one more couple of notebooks, one using audio, and I forget what the last notebook is that we'll go through next week. And then we'll be done with all the playing with diffusion and understanding stable diffusion.
Where did you get this notebook from? This is the same
Which
as
one?
I think so. Yeah.
Yeah, I told you, right? It's the same as the 9A, lecture 9A of the Fast AI course. It's here. No, this is Okay. Here. This is the one.
Okay.
Fast AI diffusion notebooks. This is the one.
Yeah, this was a folder that he referenced in his explanations, Jeremy, I think so.
Yeah, and actually, he refers to it in. He also refers to it here. This note too. No, this is the notebook. Never mind. This notebook. The or
Yeah.
in actually in this guy. The here. If you're curious, dig deep different, check out the stable diffusion deep dive notebook. And that notebook, in fact, has a link somewhere in this notebook as well. So you have a couple of different
Yeah,
ways.
I found it in my local machine. It's 8.2 MBs. Yeah, 7.93 or 8 MBs. Yeah, here.
That's
Yeah.
Yeah, see, he's this 2 months back, but since then something has changed. Because I ran it when we started discussing this course, it's worked. And I didn't encounter this problem. But now that's kind of typical of things as things keep. So let me know if you run it and out some way I'll intend to debug it. But
Yeah, sure.
okay, that's all I had for today. Any questions or comments? Thanks for joining. See you all next Saturday, which will be our final discussion relating to this whole journey.
Wow. Well, thank you very much.
Everybody.